Welcome to the Deep Dive. Today, we're diving into serverless. It's one of those terms, it feels like it's everywhere in tech. Promises to fundamentally change how we build apps. But what does it really mean for you? Whether you're, setting strategy or just trying to keep up.
Exactly. And our mission today is really to cut through the buzzwords, the jargon, and sometimes the conflicting takes you hear.
Right.
We're going to explore the core ideas, some genuinely surprising benefits, the real challenges too, and even look at what's next for serverless architecture. And we're basing this on a whole stack of reports, developer chats, case studies, the material you provided.
Yeah, the goal is to give you the insights you need to feel genuinely informed, but without getting totally bogged down in, excessive detail. Because serverless, it's not just some disruptive idea anymore, is it? It really feels like a mainstream way of building things now.
It absolutely is. The data backs that up. Over half of organizations using the big cloud platforms, they're already incorporating serverless in some way. This isn't just a trend. It's a real shift in computing.
Okay, so let's unpack serverless. It's such a confusing name, honestly. When I first heard it, I pictured, I don't know, apps running on air, which isn't right. What's the real deal?
Right. That's the classic misunderstanding. Serverless definitely does not mean no servers exist. What it actually means is the abstraction of server management from your point of view. So
Yeah.
think of it like this. The cloud provider, AWS, Azure, Google Cloud, whoever, they handle all that background stuff. Provisioning servers, patching, maintenance, scaling up, scaling down.
Ah, okay, so your team doesn't touch the servers.
Exactly. Your developers, they're freed up. They just focus purely on the application code itself. No infrastructure busy work.
That clears it up immediately. It's about who manages them. So what are the sort of key characteristics of this approach?
Well, there are three main things. First, it's event-driven execution. Serverless functions don't just run constantly. They wake up and execute only when triggered.
Triggered by what, for example?
Could be anything, really. An HTTP request coming into an API, someone uploading a file to cloud storage, a message appearing on a queue, even just a scheduled timer. Second, these functions are usually ephemeral and stateless, meaning each time one runs, it's in a totally fresh, isolated environment. It doesn't remember anything from the last time it ran. Any state you need, like user data, has to be stored externally, say in a database. This is actually key for scaling massively.
Mm-hmm.
And third, the big one financially, pay-per-use billing.
The cost angle.
Right. You only pay for the compute time your function actually consumes, often measured down to the millisecond. So if your app isn't getting any traffic, isn't running, it costs you literally zero.
And it's important to stress it's not just these little functions, right? Serverless is bigger than that.
Precisely. Function as a service, or face, like AWS Lambda, that's the most famous part. But serverless really covers a whole suite of managed services. You'll often see face functions working together with managed databases, object storage like S3, API gateways, messaging systems. The point is, your team manages none of the underlying servers for any of it.
Okay, technically that makes sense. Now, the business impact, this is where the rubber meets the road, right?
Right.
What's the compelling case for businesses? Is it always cheaper? That seems to be the big promise.
The business side is strong, definitely. And cheaper is a good starting point, though it's, nuanced. The biggest factor is often cost efficiency because you stop paying for idle resources. With traditional servers, you guess your peak load and pay for that capacity 24/7, even when traffic is low. Serverless just eliminates that waste.
So it's ideal for unpredictable traffic.
Absolutely perfect for it. Spiky workloads, things you can't easily predict. We saw that Coca-Cola example. They cut costs for their smart vending machines from, $13,000 down to $4,500 a year per machine, just by going serverless.
Wow, okay, that's a huge saving. So the insight isn't just cost cutting. It's shifting from paying for potential use to paying only for actual use. Changes the whole risk profile.
Exactly. It fundamentally changes the economics.
What about developer productivity? Does it really speed things up?
Oh, definitely. That's developer velocity. When you take away all that infrastructure management, the patching, capacity planning, provisioning, developers just focus on writing code that delivers business value, features. It speeds up development cycles, gets products to market faster. Look at Autodesk. They built their Tailor service in just 1 month using serverless.
1 month.
Yeah.
That is incredibly fast. And scaling, that's always a nightmare. It keeps ops teams awake. Is it really seamless with serverless?
It's pretty much seamless, yeah. The platforms just automatically scale from one request to thousands per second. No manual intervention. No more panic before a big launch or marketing campaign.
Okay, that's a huge operational relief.
And that leads to another key economic point, the fail cheaper advantage. Think about it. You launch a new experimental feature as a serverless function. If nobody uses it, it costs you nothing, zero. This massively de-risks innovation. You can try things out cheaply. You only pay if it succeeds.
So simplifies operations, lowers costs, speeds up development. Sounds great, but nothing's perfect. I've heard people argue that you trade one kind of complexity infrastructure for another, like debugging distributed systems. Is that fair?
That's a very fair point. It's not that complexity disappears, it shifts. Managing infrastructure gets simpler, yes, but then debugging across many small ephemeral functions, getting good monitoring, managing statering, those become the new challenges. You need different tools, different approaches.
A critical trade-off to understand. So where does serverless really shine, and where is it maybe not the best fit?
It's fantastic for real-time stuff like resizing images on upload, asynchronous backend tasks like order processing, web APIs that need to scale massively, chatbots, IoT backends, where it's often not great. Really long-running, computationally intensive tasks that are constantly busy. Those might be cheaper on regular servers. And if you need deep control over the operating system or specific hardware, the abstraction of serverless gets in your way.
Right, so not a silver bullet. Use it where it makes sense. Now, you mentioned the developer discourse, these online debates. What are the main sticking points, the battlegrounds?
Yeah, those discussions, especially on places like Hacker News, they tend to focus on four things. Cost, was it really cheaper? Complexity, the distributed systems part, performance, especially cold starts, and vendor lock-in. But what's interesting is how the conversation has shifted. It's less, is this even viable, and more, okay, when and how should we use it?
That shows maturity. Okay, let's hit performance first. Cold starts. Sounds unpleasant. What is that exactly? Why the fuss?
Right, the cold start. It's that extra bit of delay the first time an idle function gets called. If a function hasn't run in a while, the platform needs to spin up an environment, load your code, initialize the runtime. They can add latency hundreds of milliseconds, sometimes even seconds. And yeah, over 70% of users report noticing it. It can definitely hurt user experience for interactive stuff.
Seconds. Ouch. So what can you do about it? Are there clean solutions?
There are ways to mitigate it. AWS has provisioned concurrency. You basically tell it to keep a certain number of instances warm and ready. But now you're paying for idle capacity again, which kind of goes against the serverless grain for some people. It's a trade-off. They also have Lambda Snap Start for Java, which helps a lot for Java applications.
And architecturally?
Architecturally, you can design around it. Use asynchronous patterns, like put the job on a queue, tell the user got it, and process it in the background. The user doesn't see the cool start. Or you can use warmer functions, little scheduled pings, just to keep critical functions from going completely cold.
And some platforms just handle this better because of how they're built.
Yes, exactly. Cloudflare Workers is a prime example. It uses V8 isolates, not containers or VMs, much lighter weight. They claim startup times under 5 milliseconds. It pretty much eliminates the cold start problem architecturally.
Okay, interesting. Next challenge, observability. You said debugging gets harder. It feels like a black box if you can't just SSH in. How do you see what's going on?
Right, no SSHing into a function. You need a different strategy built on what we call the 3 pillars of observability. First, centralized logging. Get all your function logs into one place. Use structured logging like JSON so you can actually query them effectively. Second, metrics. Track the key indicators. How often functions run, error rates, how long they take, memory use, dashboards, alerts. This tells you what is happening.
And the third pillar, distributed tracing. Sounds like tracking a request through the maze.
That's a great way to put it. Distributed tracing assigns a unique ID to a request when it first hits your system. That ID follows the request everywhere it goes, through every function call, every interaction with other services. Tools like AWS X-Ray, Datadog, New Relic visualize that whole journey. You see exactly how long each step took, and crucially, where failures happened or bottlenecks are.
Is setting that up a huge overhead, performance-wise?
It used to be more of a concern, but modern tracing systems are really well optimized. The overhead is usually minimal, maybe a few milliseconds per hop, and the insight you gain into complex problems, it's almost always worth that tiny cost.
Makes sense. Okay, final big challenge, vendor lock-in. The classic fear, getting stuck with one cloud provider. How real is this with serverless?
It's a valid concern, definitely. The worry is if you build heavily on, say, AWS Lambda and DynamoDB, moving to Azure or Google Cloud becomes really difficult and expensive. And it can be costly. It's not usually impossible, but migrating large amounts of data between proprietary databases, that's often the biggest hurdle. Data lock-in is very real.
So how do you avoid painting yourself into a corner without, giving up the benefits of using those powerful managed services?
The key is smart architecture. The most popular pattern here is hexagonal architecture, or ports and adapters. The idea is simple but powerful. Strictly separate your core business logic, the valuable stuff, from the infrastructure plumbing. Your core logic should be pure platform-agnostic code. Your Lambda handler, or your Azure function code, becomes just a thin adapter. It translates incoming events into calls to your core logic and translates the results back.
So the adapter is tied to the cloud, but the core isn't.
Precisely. That core logic is portable. You also use abstraction layers in your code. Instead of calling the AWS S3 SDK directly everywhere, you call your own storage service interface. You can swap out the implementation behind that interface later if needed. And favor open standards where possible SQL databases, cloud events for event formats.
But isn't there a risk of over-engineering, trying too hard to avoid lock-in and slowing yourself down?
Absolutely. And this is where we need to reframe the discussion. People worry about future migration costs, but they often forget the immediate opportunity cost of avoiding lock-in. If building a perfectly portable multi-cloud solution delays your product launch by 6 months, did you really win? That lost market opportunity could be far more damaging than a potential migration cost years down the line.
Ah, that's a really interesting way to think about it, a strategic trade-off.
Exactly. Think of it like this. True lock-in cost, migration cost opportunity gain. Sometimes leaning into a vendor's powerful services is the right business decision, even if it creates some lock-in, because the speed and capability gain is just that valuable right now.
That's a crucial perspective. Okay, let's talk platforms. Picking your weapon, as you said, the market's diverse. How do you choose?
All right, they've specialized. First, AWS Lambda, the original, the incumbent, uses Firecracker micro VMs, very secure. Its huge strength is the deep native integration with like 200 plus other AWS services. Ideal if you're already heavily invested in AWS for enterprise stuff. Complex data pipelines within AWS. Pricing is granular, GB seconds, can get complex. Has the cold start issue, but they have mitigations like provision concurrency and snap start.
Then Cloudflare Workers. You said it nails the cold start problem. How?
Totally different architecture. It runs on V8 isolates, like the JavaScript engine in Chrome. Way more lightweight than VMs or even containers. And it runs across Cloudflare's massive global edge network, hundreds of cities, so near zero cold starts, like under 5 milliseconds. And the code runs physically close to your users, slashing network latency. It's the leader for pure speed, especially latency-sensitive APIs. Plus, pricing is often based on CPU time, not just wall clock time, which helps with IO-heavy tasks. Downside, more constrained environment, mainly JS, TypeScript, Wasm.
And Vercel Functions, popular with the front-end crowd.
Yeah, Vercel is all about the developer experience, especially for front-end teams using frameworks like Next.js or Nuxt. Technically, it often runs on AWS Lambda under the hood, but it abstracts almost all of that away. Zero config deployments, seamless CI/CD, preview URLs, global edge caching for static assets. It's incredibly smooth. Pricing is bundled into their platform tiers. It inherits Lambda's cold start potential, but uses smart routing and caching to minimize the impact.
Okay, so quick summary. Lambda for deep AWS integration. Workers for edge speed and low latency. Vercel for the slickest front-end dev experience. Got it. All right, moving on. Just picking the platform isn't enough. You need resilience. How do you build serverless apps that are robust, maintainable, and can handle failures?
Good architectural patterns are key here. For complex processes involving multiple steps across different services, like booking a trip with flights, hotels, cars, you need a way to manage consistency. The Saga pattern is common. It's a sequence of local transactions. Each step does its thing, but crucially, each step also has a way to undo its action, a compensating transaction if a later step fails.
That sounds potentially complicated to manage manually, that whole compensation logic.
It can be. That's why orchestration tools like AWS Step Functions are so valuable. You define your whole multi-step workflow visually as a state machine. Step Functions handles invoking the lambdas, manages state between steps, handles errors, retries, and can trigger those compensation actions automatically based on your logic. It simplifies Saga implementation a lot. We also heavily rely on asynchronous patterns. Using queues like Amazon SQS decoupled services, the thing sending the message doesn't need to wait for the receiver, smooths out traffic spikes. And the fan-out pattern, maybe using S3 events or SNS topics, to trigger multiple Lambda functions in parallel to process something, like generating different image sizes from one upload.
And managing state. If functions are stateless, where does the data live?
Yeah, the stateless mandate is core. Functions don't remember things. So state must live externally. That's the external storage pattern. Use scalable, durable stores like DynamoDB, NoSQL, RDS, SQL, or S3, object storage. For really critical stuff, there's the storage first pattern. When a request comes in, you immediately write its essential data to a durable store, like an SQSQ or DynamoDB table, before you even start processing it. That way, if the function crashes midway, you haven't lost the request data. And for really complex state needs, patterns like CQRS and event sourcing come into play, but that's a deeper topic.
Externalize everything important. Makes sense. What about testing these distributed beasts?
Testing needs a different mindset, too. The serverless testing pyramid is a useful model. At the base, lots of fast unit tests for your core business logic, isolated, using mocks. Then fewer but critical integration tests. These test your function with the actual cloud services it talks to, testing IAM permissions to DynamoDB, for example. You usually run these against a real cloud environment, like a dev account. And at the top, a small number of end-to-end tests simulating a full user journey. The key takeaway is test in the cloud for integration and E2E. Local emulators often don't catch everything.
Right, test against reality.
Yeah.
And deployment. How do you release updates safely?
Modern CI/CD is essential. We use deployment patterns like canary deployments. You release the new version to a small percentage of traffic, first say 5%. You monitor closely. If it looks good, you gradually increase the percentage. If things go wrong, you roll back quickly with minimal impact. Or blue-green deployments. You deploy the new version to a completely separate parallel environment, green. Once it's tested and ready, you switch all the traffic instantly from the old blue to the new environment. Zero downtime.
Okay, solid practices. Now, looking ahead, the future. Edge and WebAssembly keep popping up. Are these the next big things in serverless?
I'd say they absolutely are. Serverless and edge computing go hand in hand. It's about shifting compute away from those big centralized cloud data centers out to thousands of smaller points of presence. POPs, much closer to end users. The big win. Dramatically lower latency, crucial for real-time APIs, online gaming, IoT data processing, plus it helps with data residency rules, keeping data within a specific region.
And WebAssembly, or Wasm, sounds like it could change the underlying runtime itself.
Wasm is potentially revolutionary for serverless runtimes. It's a portable sandbox binary format. Why it matters? It's incredibly lightweight. Startup times can be near instantaneous, under milliseconds sometimes. That's way faster than containers or micro VMs. And it's secure by design.
So is Wasm basically the ultimate solution to the cold start problem?
It really looks like the technological endgame for cold starts, yes. Platforms like Cloudflare Workers using V8 isolates which run Wasm already show this potential. But what's also fascinating here is that Wasm breaks language lock-in. It acts as a universal compile target. You can write code in Rust, Go, C++, AT, Yace, whatever compiles to Wasm, and run it on any compatible runtime. This enables a bring-your-own runtime model. It decouples your application code's language from the cloud provider's specific runtime offering. Huge for portability and competition.
Wow, that really opens things up. One last thing on the future, will serverless always be stateless? Or is that changing too?
That's evolving too. We're definitely seeing movement towards stateful serverless, things like Cloudflare's durable objects, and ongoing research into dedicated serverless state management systems, or SSMS. The aim is to bring easier state handling and database-like consistency directly into the serverless model, without losing that core elasticity and pay-per-use benefit. Still early days for some of it, but the direction is clear.
This has been incredibly insightful. Okay, let's recap the key strategic takeaways for you, our listener, navigating this serverless world. 1. Think serverless first, not serverless only. It's a powerful option, not the only option. 2. Pick your platform based on your workload. Remember, AWS Lambda for the AWS ecosystem, Cloudflare Workers for edge latency needs, Vercel for that smooth front-end DX. Don't follow dogma. 3. Architect for portability from the start. Use patterns like hexagonal architecture to keep your core business logic safe. 4. Invest seriously in observability. Structured logs, metrics, distributed tracing, they're not optional in complex systems. 5. Understand the money. Get familiar with the billing models. Monitor your costs carefully. And 6. Keep an eye on the edge and WebAssembly. They're shaping the future of compute.
Absolutely. It's a fast-moving space, but the potential is enormous.
So what does this all mean for you? Here's something to think about. Consider that idea. True lock-in cost equal migration cost opportunity gain. For your next project, when might leaning into a specific cloud provider's services, even if it feels like lock-in, actually be the smarter business move? Could that velocity gain, that ability to grab a market opportunity faster, be worth more than the potential cost of migrating later? What value are you willing to trade for speed? Something to mull over as you plan your serverless journey.